Question 6. The student determined the relative molecular mass, the MR, of an unknown volatile. Volatile means that it evaporates at a lower temperature. It's got a low boiling point. In an experiment as shown in figure 5. So they've got the liquid in here. They've squirted it into this larger syringe with a heated oven, so trying to get it hot, and then it looks as if they're measuring the mass of this small syringe before and afterwards, presumably so they can work out how much Y has been injected into the larger syringe. They know the temperature of the oven, they know the pressure, and they know the increase in volume of the gas syringe after they've injected it. So what volume Y is at this atmospheric pressure and at this oven temperature. So it's heading towards PV equals nRT. Okay, so let's try and get these PV equals nRT. Let's try and get these experimental values into the right units and calculate some masses and so forth. So first of all, the mass of the Y, the mass of the syringe before injection was 10.91. After some of Y had been injected into the larger syringe, it's gone down to 10.70. So if I subtract the two, I've added 0.21 grams of Y from the small syringe into the large syringe. So I've now got 0.21 grams of Y in the large syringe. The oven temperature, degrees C, well, for PV equals nRT, P, pressure, T, temperature, needs to be in Kelvin, so I need to add 273 to that, so that comes out as 371.1. The pressure is in kilopascals, it needs to be in pascals. To turn kilopascals into a lower unit value of pascals, I multiply by 1,000, so 102 kilopascals is 102,000 pascals. And here, centimetre cubed, I've got to get it up into decimetre cubed, into a large unit value, and then decimetre cubed up into meters cubed. So for PV equals nRT, then V, the volume, is in meters cubed. So centimeters cubed up into decimeter cubed, smaller up into larger, I divide by 1,000, then to get decimeter cubed up into the next unit value, which is even larger still, I divide by 1,000 again. So it's 85 divided by 1,000 divided by 1,000 again, 0.00085 meters cubed. So I've got some values now that I can use in PV equals nRT. I know I'm going to be using PV equals nRT because they'll give me temperature, pressure, volume, mass, and things like that. Okay, let's have a look then. Define the term relative molecular mass. Oh, I've been given a gas constant, so it's definitely PV equals nRT. So MR is the average mass of one molecule divided by 1/12 the mass of a carbon-12 atom. That's just something to remember. Okay, the next stage is that you've got the mass of Y and PV equals nRT. I've put the number in for P, 102,000. I've put the number in for V in meters cubed, 0.00085. N is the number of moles of Y. 8.31 is my gas constant, and 371 is my temperature in Kelvin. So I'm just going to multiply these out now. So 102,000 multiplied by 0.00085 is 8.67. N is remaining the same. 8.31 multiplied by 371.1 is 3083.8. So I'm going to divide both sides by 3083.8. So N, the number of moles, is 8.61 divided by 3083.8, 0.00281. N is the mass divided by MR. Rearrange that, so 0.00281 is 0.21 divided by MR. Rearrange that, MR is 0.21 divided by 0.00281, 74.7. I'm going to put it, I've got it to three significant figures because other values are to three significant figures. If I just go back to the first part of the question, then some are to four significant figures, but I always take my lowest significant value, 85.0, so for example 102 kilopascals, 98.1 degrees C. They're all to three significant figures, so I take the lowest significant figure value to base my answer upon. Some of the liquid injected didn't evaporate because it dripped into the gas syringe outside the oven. Explain how this is going to affect MR. Well, less Y means that the volume is going to be lower because you've got less injected into the syringe. PV equals nRT. So I could rearrange that, so PV divided by RT is N, the number of moles. So if the volume is lower on this side, V is lower, then N is going to be a lower value. N is mass divided by MR. If N is a lower value, mass equal MR is mass divided by N. So if NR is a lower value, then mass divided by a lower value is going to give a larger MR. So MR is larger than the real value.